There are other methods also to do some cryptanalysis. As we said, some statistical information for double and triple letter. For instance, the most frequent double letter in English are TH, HE, AN, IN, and so on. And the most frequent triple letters are, for instance, D, and ENT, and so on. Okay. Hence, an attacker can be able to calculate letter frequencies for ciphertext and compare the distribution of frequencies of ciphertext with the known frequency distribution for that language. And as you can see in this slide, for instance, this is our ciphertext. By analyzing this text, you can see that letter B has the most frequency. Hence, we can say that B could be equal to E, and etc. And for diagrams, here in this text, NC is repeated more than other diagrams. Hence, it could be in. And finally, as you can see, for diagram, UKB is the most frequent. Hence, we can guess that it is the encryption of D in English. Okay? Hence, there are many examples of cryptanalysis that can be done over a ciphertext encrypted by Cipher encryption method to find the real plaintext. You can read these slides later. Okay, we can say to make this method more complex and sophisticated, we can use N substitution ciphers instead of simple one. What does it mean? It means that instead of substituting only one letter by one letter, we can use several, or you can use a word to encrypt your text. What does it mean? It means that instead of, for example, using one letter, you can use 4 letters. And for each new plaintext symbol, you can use subsequent substitution patterns in a cyclic pattern. Okay, you may ask, what is the advantage of this method? We will explain. But you can imagine and thinking about that. There's another method, or there was another method, because all these methods that we are describing here are broken. The method Vigenère cipher use this sophisticated substitution. We can consider the set of all Caesar ciphers. Then you can consider one word as your secret key. For instance, security. Okay? Then each letter is encrypted using this word. security, and we repeat this pattern to encrypt our plain text. And for decryption, simply we need to reverse this method. Okay? For instance, in Vigenère cipher, consider that your keyword is this one, deceptive. You need to repeat this word until the length of your plain text. Then each of your letter here is shifted by the corresponding letter in the ciphertext. What does it mean? It means that D is shifted by W. Sorry, it is not a good choice. What does it mean? It means that we need to shift letter D, the first letter D, by W, which leads to Z. Then for E, we need to shift E by E, which leads to I, and so on, till the end of your plain text. As you can see here, your key has been repeated. The advantage of this method is that the frequency is broken. What does it mean? As you can see here, the first D is mapped to Z. The second D is mapped to R. And for instance, if you see several Z in your text, they are not the encryption of the same letter. Hence, in this way, some statistical information of plain text are broken and cannot be used for brute force attack. Okay? As you can see here, the frequency are obscured, but not totally lost. Okay? Anyway, this method has been broken as well like the other methods. I explain rapidly how this cipher method has been broken. For the first time, you need to break this method or to do a brute force attack. You try to guess the key length. Normally, for instance, in English, the most length of the word is equal to 5. Hence, the key length could be 5 at the first time. And then you try to subdivide your ciphertext into some sub-ciphers of length 5. and then you can do your cryptanalysis for each parts, and then you can continue this method, but for instance, but by the words of length 5, 6, etc., etc. Anyway, the Vigenère cipher method is broken as well, like other methods. Okay. In order to reinforce the method that we explained, rotor machines was used to make more complex ciphertexts. In this method, a series of rotations in a cyclic method has been used. Okay? What does it mean? It means that you can consider a rotation in your alphabetic. For instance, I can explain in the next slide. It's so simple. This is an example, a simple example of a rotor machine. As you can see, there are several rounds. In each round, we change the position, or we map each alphabet to another one. For instance, for the first time, A is mapped to C, D is mapped to B, and the output of the first round is the input of the second. Then this output is mapped randomly, and etc. For instance, in this example, after executing 3 rounds, you can see that letter A is mapped to letter D, B is mapped to C, and so on. And in this slide you can see that an example of Rotors that was used in some mechanical ciphertext machines. And also Enigma Rotor machine was another example that has been used in the second worldwide. In this, for instance, in Enigma machine, 4 rotors have been used. Hence, you can imagine that for English letters of 26, which with 4 rotors, we will have the total rotation of 26 power 4, which is equal to 2 power 18. For those time, this key size was big enough, 2 power 18, but nowadays never it can be secure. It can be broken even by your calculator, and not at all secure. Okay, you may ask why we are learning those methods which are not secure. There are several reasons for that. The first is that you need to know that any method that one person creates, this method is not at all secure. And also you know how several encryption systems can be broken.